Good evening, Sean here, Mountains Garage. It's a rare late night episode of the ongoing saga of the 72 Nova Turbo, maybe twin turbo, probably twin turbo, LS project. When I woke up this morning, I came out to the garage, decided the next thing I should do is build the driveshaft loop. So I dug out some stuff for that and was just about to run some string to mock up the driveshaft when I realized I'll just go ahead and build the driveshaft, completely derailing my original plans. And I spent the rest of the day in and out of the garage, almost finishing it. But this video started getting really long, so I'm obviously shooting this afterwards. It's sitting here ready to assemble, which I'll do tomorrow. So that'll be the second video, I guess. I'm gonna install the driveshaft and then build the driveshaft safety loops. Two of them. So here's everything I accomplished today. It was a pretty good day, and I'll catch you in a minute. I've been collecting driveshaft loop parts for a while. I believe I bought that at a swap meet. Got a cross member, got some random tubing. I got two bends to work with. I like the way the loops that I have fit around here, and this is a nice structure as well, but I'm going to go 360 and behind that. The 71 Nova proves that this is, will contain a drive shaft, at least help it not to come through the floor too bad. So I believe I'm going to run a cross member across, 360 loop, and back over to the other side. I want to get it as high as possible because I don't want to interfere with whatever my exhaust system's going to be. So I was about to string some string from yoke to yoke, so I can mark out, work around where the drive shaft will be. When it occurred to me, why not just build the drive shaft? Sorry about the light, but I went ahead and measured from the housing to the end of the yoke to make sure this matched up with what I'm actually going to use. And then measured the likely candidates, and from where it mounts to the housing to the end of the yoke is 9.5 inches, pretty much, just like the one in the car. So center of the rear pinion yoke to center of my transmission yoke that I slid out about 3/4 of an inch or so from bottomed out, slid it back out. I'm 54 inches on center. That's what I'm going to go with. Believe it or not, the driveshaft tube, they ship it just like this. So both ends have slight dents in it, so I have to cut it back first, then measure and cut what I need. And the yokes are a couple thousandths bigger than this. So I have to mount them in the lathe this way, grabbing them internally. And I'm machining between the chuck and the yoke spinning around. It gets pretty tight, but it's doable. A 4-jaw chuck holding this would probably be more efficient, but I get away with it the other way. I've had good luck getting splicer parts from these people. So I got splicer yokes, splicer joints. Another ad I saw, I bought a pair of splicer yokes and they sent me these, which are not the same. They're the same dimensionally. I'm going to assume they're of lesser quality, and I'll actually use them on the 71. They're still a big 1350 shaft and they'll be fine, but the metal in these looks like it's tighter, if that makes any sense. So I'm going to use the splicer yokes. This splicer yoke is made for 083 wall drive shaft, which is what this is. But tolerances being what they are, a couple thousandths when you go to shove that tube end in is a lot. So I just tune it up a little bit in the lathe. This is my preferred cutting method. A little bit of cutting oil and the old pipe cutter, nice and straight. I don't believe you can clean and deburr the inside of the shaft too much. These 3M pads are awesome. I hit it with a hand file first to remove the tiny little burr left by the tubing cutter. And then I sand inside with these. They're a rubber sandpaper, amazingly resilient. I use them on roll cage tubing. I need to get more. The part number's cut off, but I'll figure it out. So now the offset between here and the center of the yoke is about, depending on how you read the tape measure, 2 1/16, 2 1/8. So that's times 2 off my 54-inch measurement. So my shaft is just slightly under 50 inches. The tubing, I should say. Mark can cut the other end next. And the fact that they don't ship it in a package is bad enough. Then they put shipping labels all over it, and they don't exactly fall off. I'll spend more time getting this label off than I probably will building the drive shaft. This is how close I have to cut to the chuck with the yoke mounted backwards. But it works, and I'm done. I'll take a little break for lunch, but we got it pushed together. It's 54 inches on center exactly. I use the parallels to kind of take the strain off the shaft. The ends are tapped in tight anyway. And I use the bench to phase it. And it's chrome moly, so I've got to TIG weld both ends. I used to just tack it and go ahead and assemble it in the car. Put the dial indicator on it and check for run out. I've never had to change anything, so I'm going to skip that step and just weld it up and hope for the best. If it shakes or vibrates, well, I'll know I made a mistake. I built the drive shaft in that car and I went 179.99 about 150 times. Nice and smooth. With a Lenco and about 1,450 horsepower. It was very violent. So my little LS turbo with a turbo 400 and a 350, 60 gear, whatever I put in it, is probably going to be a little milder. This car went 107 60 foot. I've covered it in my drive shaft video if you happen to have watched it, but I'll say it again, a steel drive shaft is about the worst choice you can make in a high performance vehicle. This thing, if things go wrong, wants to get up inside the car with you and take your arm off. An aluminum shaft will break into bigger chunks, they say, maybe shatter, and a carbon fiber will just turn to powder. And they're priced accordingly. Steel's the cheapest, aluminum's in the middle, and carbon fiber is over $1,000, but definitely where it's at. Cheaper than an arm. If I had modified floors, tin floors or aluminum floors, I wouldn't be sitting next to a steel shaft. In any vehicle with aftermarket floors, be it steel or aluminum, most fast cars you have to have a steel driver's floor, but the transmission tunnel can still be aluminum. You need to cover at least the front 12 inches of the shaft with a complete 360 enclosure, which is a whole nother floorboard, if you will, around the shaft. And on the 9-inch Ford, there's another 6 inches covered back here. Plus, the chassis makes a safety loop as well. So, for this car, we're going to go with the drive shaft loop, another drive shaft loop, and factory floors. All welded up. Before I bought the new gas lens, the Monster 12 cup, all my welds were gray. Now I get rainbows. That was ER70S6 in 1/16. Blue tungsten, 3/32. The Monster 12 gas lens at 22 CFH. 90 amps, floored the whole time, and I was going really slow. But it doesn't turn gray, it just, in some places it has no color, which is, I guess, what you look for. You know, pretty good for me. But I haven't changed my technique any, just the equipment. I welded it in quarters. When it came down to the last quarter, I was going to let the whole thing cool. Again, worried about pressure. Then I figured it was so big, it would never build up enough pressure, so I just went ahead and finished. And it worked out. Didn't blow the weld out. If it was smaller, it might have. I'd really like to assemble it now and put it in the car, but I guess I'm going to spend some time scraping those stickers off and paint it, and then I'll assemble it. It'll look better in the long run. Pretty, but somehow I'll come out here in the morning, and despite how careful I was, something will happen to it. It'll either stick to the cardboard, or there'll be a blemish on it somewhere. But we'll see. I'll be back in the morning. Satin granite was the color. Rust-Oleum. It's only a few hours later and I couldn't wait. And I had a feeling it was going to stick And I got one spot to touch up. Still kind of tacky. I should probably wait. But I wanted to finish up this video because it's getting long. And the only thing I did not discuss, I've done a video on U-joint installation, so I'm not going to actually film that. But this is your drive shaft yoke. It sticks into the transmission. To go forward, the engine turns this way and the drive shaft turns this way. If you place the grease fitting, now the grease fitting type U-joint is the weakest choice in Spicer. It's still a very strong joint. It's a 1350. I have a bunch of them. I'm going to use it. They make a sealed for life, which has less holes drilled in the cross. And other brands, you can also buy a solid. If I was a manual transmission application, I'd definitely be going solid. At least probably the sealed for life. It's probably slightly stronger than this, but this is still a 1350 joint. Very rugged, somewhat misplaced with a billet yoke. But as these are just cast yokes, so it's a hodgepodge of stuff, but more than adequate for what I'm doing with it. But anyway, back to what I was saying. The engine rotates and the drive shaft rotates this way. I'm the rear end staring at the transmission. It goes this way to go forward. With the cross place like this, with the U-joint grease fitting right here, it would be installed like this. It's under compression. The drive would be compressing it. If I put it this way, the driven yoke would be under tension, and it's weaker that way. They claim, this is from the experts. So in this case, my cross is going to go like this with my U-joint in the upper left-hand corner. It would be the same if you put it in the lower right-hand corner. It would still be being compressed by the drive. Does it really matter in the big picture? Who knows? I'm not the U-joint expert. I'm just regurgitating information that I picked up years ago. So I'm going to install it just like that. There's more room in this yoke to grease it than there is this direction. So it's going to face just like that. The only tools I need to install it are a tiny little hammer and a pair of needle nose. If you search online, you can buy a ready-made drive shaft, 1350 series, 3-inch, like this one, with the shaft, the end yokes, and the U-joints installed. They won't give you the slip yoke, for somewhere between $220 and $250. It cost me $110 for this piece of drive shaft tube, and about $60 for the yokes, and about $20 each for the U-joints. Do the math. There's no savings in doing it yourself. Well, minimal savings for doing it yourself, and it's a lot of work. I mean, I've spent probably 3 or 4 hours doing it this afternoon, but that's the story of my life. I still saved something, and I'll use that something for something else. If you have watched my drive shaft video, and yes, I do have one, most of the drive shafts that I could get locally are going to be some type of steel. It could even be chrome moly like this one, but they still MIG weld them with giant welds, where this one has tiny welds. I believe that has a lot to do with the balancing. If this shaft vibrated, I would either throw it away, remake it, have it balanced, cross that bridge when I come to it. To date, none of them have. I saw a video last night of a cool car being built, and they were talking about the carbon fiber drive shaft they're buying for it. And those are so minutely balanced that the SFI sticker that they apply to the drive shaft is how they balance it. The weight of the sticker makes a difference. Now, for my farm boy drive shaft, let's just say it's not that close, but I don't think I'll ever feel a thing. I've been 180 miles an hour with one. This car might go 160 on a good day. Someday, maybe, probably, who knows. Anyway, take it for what it is. Thanks for watching. Tomorrow we'll build a containment device for this drive shaft, so when it fails epically, it won't come meet me in the car and want to ride next to me. Take her easy, like, share, subscribe. next time.